Very pleased here that I can be here to introduce you to self-sovereign identity, a new technology for digital trust in the future. Self-sovereign identity is mainly about exchanging verifiable credentials, so credentials about yourself. It can be your name, last name, but even like your income or employer statement, for example. And I will tell you some more about what self-sovereign identity exactly is. Well, my name is David Lamers, and I'm working as blockchain specialist in the blockchain team of Rabobank. Currently, we are with about 10 people working full-time on blockchain. So there are some specialists, but also some engineers, like Marnix is also here. He's identity engineer mainly, but also focusing on other projects. Well, today I will just quickly introduce you to the concept of self-sovereign identity, like what's important in self-sovereign identity and how does it work. I will dive more deeper into 3 use cases we are working on at Rabobank, or we are working on even more, but there are 3 important ones having the highest potential that we can see right now. Give you some live demo using a proof of concept identity app we made. And in the last part I will quickly touch on some technical aspects, but it will be really short since we only have 1 hour. So about identity. You probably all know where it all started, like we have the siloed identities. We used to always have them. So when you identify yourself on the internet, you most of the times have an account at a certain website where you registered a few weeks, months, years ago. And for each website you have like a different identity. You just entered some information and they trust that you are that person, or you just entered some random information. But it's you cannot validate the information that you entered onto the website. And for every website you have like a different identity, or at least a different account. Then we slightly moved on to like more centralized identity solution that you can use on multiple websites. So, for instance, your Facebook login, you can use it for Spotify, for Tinder, but you still rely on a central party providing the identity solution or your authorization solution. And then now we have like more open standards, like IOTA. They are more open source. You don't rely on a central party. They are just protocols, so you can have like a central or one account for a lot of websites. But in the future, or these years, we will move on to self-sovereign identity. Self-sovereign identity is basically where you are in fully control of all your credentials, where you don't rely on a central party. And it can be even more than just your credentials to log in. It can be also personal information like your driver license and your income. So the problems of today's internet is that we don't have like an identity layer. There's, as just explained, you make an account for every website, but there's no identity layer that you can use like HTTP. Well, we see an increasing number of frauds and data breaches, like Equifax, for example, where identity honeycombs are they hack into them, and a lot of data is lost, like personal information. And we always rely on one central party. With self-sovereign identity, we make sure that all the data is yours. So the data is on the edge device most of the times, or you can rely on, for instance, an identity hub or encrypted data vault, however you want to call it. They provide the identity solution. They provide a safe way to exchange your credentials, to issue them, to verify them. And it also comes down that since all the data is saved on your mobile edge device, there's no central place which is interesting for a hacker. So self-sovereign identity, you're fully in control of all your data. You don't need like a lot of cards in your phone or in your wallet, I mean. You don't have like an archive with all documents about your income, about your tax aangifte that you did. And it also is a solution for challenges that companies currently have with GDPR, because they have really challenges on for how long can I store personal data for my customers, for which data can I ask. Since all the data stays at the customer, the companies don't have to worry about those things. So with self-sovereign identity, you basically have like, there's one, your key. There's one key that gives you access to all your personal data. And that personal data can still come from trusted sources. So it can be that the government provides your passport, that Rabobank provides your bank account number. But there's one central place which gives access to it. And you can use these credentials for services from third parties. So for instance, if I want to go to the Albert Heijn to buy like a bottle of alcohol, I can provide, or I can prove that I'm older than 18 using the passport details in my identity wallet. And it can even be that I just show the attestation, so that I can prove that I'm older than 18, but I don't have to share the day that I was born, or the year that I was born. So it can also provide a solution that I don't have to share too much information. So I can do some selective disclosure on data attributes that are in my identity wallet. There was a very interesting paper written by Christopher Allen about self-sovereign identity. So he wrote a paper about what true self-sovereign identity should be, where you don't rely on any central database. Well, there are 10 of them, a lot. But I think the most important one is control, that you're in fully control of the data, of giving consent to other parties. So you decide to which party you share your data with. Always have access, so you don't need like you know where it is, and you can see which companies have access to your personal data. There should be transparency about standards that are used, but also about protocol and exchanging of the credentials. Persistence, so data cannot be deleted. So we also see some identity solutions where the data, so your attributes, your verifiable credentials still stay with the issuer. But it might be that, for instance, the issuer of the data goes bankrupt, so the company goes bankrupt, doesn't exist anymore. We prefer that those data still exist on your mobile device, so that you can still use those data. For instance, when you received a certificate from a learning institute, you still want to use it in the future, even if the learning institute doesn't exist anymore. Portability, very important. So you don't rely on a single identity provider. You must be able to switch from identity provider. Interoperability, also very important. We know some solutions in the Netherlands. Maybe you've heard of Irma or the TU Delft working on an identity solution. There are like maybe hundreds nowadays of identity solutions in the world, like self-sovereign identity solutions. And it's still a challenge to have interoperability between them. And I'll explain some more about it later on how we solve those issues. Explicit consent of sharing your data is very important. Minimalization, so not making copies of the data every time you use a third-party service. And the rights of users should be protected, but I guess that's something already coming from GDPR. Within Rabobank, we are working on like a lot of identity use cases, as already explained. And we do that within some collaborations within the Netherlands. So for instance, we have the Dutch Blockchain Coalition, where all banks are involved, the government, some consultancy companies, IT companies. And a very important work stream there is identity. We have decryption in the southern part of the Netherlands, also working on identity together with, for instance, the Chamber of Commerce and TNO. Big parties there involved in self-sovereign identity. And also within our team, it's very important, the topic of identity, because we foresee that like every blockchain application needs some kind of identity, because you want to determine who is who on the blockchain, but also outside blockchain applications, it's an important topic. Yeah, so identity is one of our important building blocks as blockchain team, besides value transfer and signing. So those are components we identify that are mainly used in almost every blockchain application. For the proof of concept for the use cases we are doing, we are working on some identity app. So we're developing an identity app for the proof of concept. Doesn't mean that we will put it in the market later on, but we are learning on the use cases and learning on what we should do as Rabobank, as a company, on self-sovereign identity. Where we are working on is like an identity app and like an identity platform to issue and verify data. So on the issuer side, we have a component, it's called the issuer backend, which can issue credentials. So like we make sure that today's existing systems can connect to an identity platform that we are building. So they can share personal information to the backend, which then converts them to verifiable credentials and puts, for example, the decentralized identifier in the blockchain. So that's the confirmation saved in the blockchain, but the decentralized identifier, it's an open standard from W3C, and it's just a random number that's put in the blockchain. So it's not personal information, it's not encrypted personal information, and even not hashed personal information, because you should never save personal information in the blockchain, let that be clear. And on the verifier side, a company that wants to use the platform can, for instance, say, I want his last name, first name, and then the verifier receives that information, and the backend is automatically verifying that the data was not manipulated, that it's coming from a trusted source, and that the data is still valid. So blockchain, for instance, also gives the ability to revoke credentials that were issued in the past. So why do we work on SSE at Rabobank? Well, we have a lot of data from the customer. So we want to explore like how can we give it back to the customer so that he can reuse it for different processes from third parties. So it can, for instance, be that we give a credential where the income or loans that we have from a customer are in the identity wallet. We can also work with verifiable credentials within our business processes. So I'll also tell you something about mortgages. We want to improve the mortgage application process, which can be quicker using self-sovereign identity. That's I think, the most important points for us. Then a little bit about the use cases we are working on. It's a long list. Oh, sorry, it's still in Dutch, some parts. So on top are the most important ones for us, and I will mainly explain about those three. So mortgages, social housing corporations, and the employee wallet are three initiatives we are mainly working on, and for almost all of them we will still do a pilot this year. So to start with the employee wallet, it's mainly an identity app. So it can be like even a generic identity app. It doesn't have to be like an employee wallet focused on only a wallet for the employee. But it does save like certificates or diplomas or trainings you did. So you cannot like make a fake LinkedIn profile or fake resume. But it's all validated information, validated by the Learning Institute. We're mainly working on this because we see like a different environment or changing environment regarding working at the company. People change more often from employer. Everything is more flexible, and we want to stimulate employee mobility. So that's why we want to make sure that they are in control over their own data, so that if, for instance, they did a training at Rabobank, they have a proof of that and they can use it even at their new employer. What we are doing is mainly we really like to start small when we are doing like innovation projects. So we'll just focus on 2 data points for the pilot we will do this year. So the pilot focuses on WFT certificate and references in like an identity wallet. And the pilot will be that you go to like an, we have, for example, NCOE in the Netherlands. They provide WFT certificates. And the pilot will be more or less that 100 employees from Randstad are onboarded at Rabobank. And using the identity wallet, like we can improve the process so it can be quicker and even more compliant. But in the future, the data in the identity wallet can be extended to all work-related information, and even like in the future be your personal vault with all the information in there. So currently, the biggest frictions we have identified when onboarding new employees are mainly that we spend a lot of time on verifying all the certificates. They have to be manually verified, and even if somebody retrieved some diplomas outside of the Netherlands, it's very difficult to verify them, and we even hire like external parties to do so. All data is not validated, so it's not like signed in a way that you cannot fake it. So you can make easily like a fake paper, just plain paper with that you did some training or retrieved a certificate. While in the identity wallet, everything is cryptographically signed. And for us, it's really complicated to be compliant right now, because the WFT certificate is the certificate that everybody in the Netherlands who has customer contact within a bank should have. So it's demanded by the government, but we cannot really be compliant, because all we ask right now is just a PDF or a picture of their certificate, and that's for us enough to onboard them. And in the identity wallet, we can verify everything that's coming from the right source, that's not manipulated. I think these slides I already explained. Spend a lot of time. So this is mainly how our innovation funnel looks like. When you have an ID, for instance, a new use case for the identity wallet, which can come up during IDH sessions. So we generate new IDs, and when we think that we have like identified a problem and maybe want to provide a solution as Rabobank, then we go to problem fit. So then we validate with customers, in this case employees, if they really face problems changing employer, and also the onboarding time, if they think that's taking too long and it's really an issue for them. Then we validate more or less like the solution, so we make some prototype mock-ups if this is the solution they wanted. And for the employee wallet, currently we're on the solution fit phase. So that means that we have built more or less the identity platform, and are now working on the employee wallet itself, so the app itself. And hopefully, we can do a pilot this year with 100 employees. Then for social housing, it's for social housing in the Netherlands, you have social housing corporations providing the houses, but when you apply for such a house, you have to give them a proof of your income, because your income cannot be too high to apply for social housing. And And that process to do like an income test is really complex in the Netherlands right now. Like all social housing corporations together spend like 17 million euros on it, because I think like a 0% error rate is allowed by the government. So everything happens with the 4I principle. When like the income is entered into a system, 2 people are doing that. And we have a lot of social housing units in the Netherlands. So that makes it a pretty expensive process. And the Dutch government have to come up with a solution this year for that process. Well, because they require such an extensive process, which makes it very expensive for the housing corporations. So what we want to achieve is appoint a social housing unit to each citizen in a secure, easy, and trusted way. This means that also in this process, you put your personal information in the identity wallet, or you retrieve it basically. You also retrieve your financial information into the identity wallet. And what's unique in here is that we also use zero-knowledge proofs. So that means that when you apply for a social house, you don't have to share your income. You only have to share a cryptographic proof that your income is in a certain range. So the social housing corporation asks to the identity wallet, is the income between 10 and 40,000 euro? And then the identity wallet answers with more or less a yes or no, but it cannot be fake because it's a cryptographical proof. So also here, like we did the validation process, where we identified that for the consumer, he's sharing way too much data. The process is very complex. He doesn't have control over his data anymore when he shares it. So he's not sure if the social housing company shares it with other companies, for example. And the process is pretty long, because like now you upload a PDF of your income statement, for example, and somebody has to manually verify it. And also on the social housing corporation side, they have to spend a lot of hours to verifying your income, entering it into new systems, the 4I's principle. And also something we see in most use cases is that files are delivered incomplete. So people upload a PDF, but most of the times there's an error in it because some data is missing. So they have to call the customer again, ask for a mortgage. For instance, the income statement is a document that's often delivered with errors. And with self-sovereign identity, you can immediately verify all the data that is in the document since it's structured. So that's also very beneficial. I have a quick video on we made during a hackathon. So that was a hackathon from the Dutch government. Marnix and I joined for a weekend. It was pretty cool, and we won it. So that's why it gave us the opportunity to do a pilot with the government this year. I'm not sure if the audio is working.
Leon heeft een woning toegewezen gekregen van zijn woningcorporatie en gaat naar de website om deze te accepteren. Om de woning te accepteren moet Leon een inkomenstoets doen. In het proces krijgt hij de optie om de MyID-app te gebruiken. Leon heeft de MyID-app al geïnstalleerd en gaat zijn inkomen ophalen bij Mijn Overheid. Zodra hij zich geauthenticeerd heeft met DigiD, scant hij de QR-code om zijn geregistreerd inkomen op te halen. Na het scannen komt hij automatisch terug op de website van de woningcorporatie. Zijn inkomensgegevens staan nu in de MyID-app opgeslagen. Leon gaat nu de inkomenstoets doen door middel van het scannen van de QR-code. De app genereert een zero-knowledge proof en hij deelt deze met zijn woningcorporatie. De woningcorporatie kan deze geautomatiseerd valideren en Leon direct definitief accepteren voor de woning.
Okay, so that goes a bit quick, but I'll explain it later when I do a demo as well. Are there any questions, by the way, about anything I told you?
So the income was not known to the government here, or it was?
Sorry?
The income of
Yeah.
the person who did scanning
Yeah,
was not known at the government database?
yeah, the income was retrieved like from the government website.
It was.
Yeah.
It was not scrambled or whatever, to be scrambled by the person's key or something?
No. So when you applied for the social housing unit, the website asks like, do you already have your income in the mobile apps? And then he clicked on no, and then you go to the what was it, Belastingdienst, right? The tax authority, where the QR code was scanned, and with scanning the QR codes, you retrieve personal information to the identity wallet or share it with somebody.
So when the housing corporation gets your yes or no, you're in the right income bracket, doesn't that leak any information? I mean, they know in what bracket you are, so that's some knowledge about you. Now, does a zero knowledge proof doesn't leak that information?
The zero knowledge proof doesn't like share the information, like the exact information, but it shares that your income is in a certain range. So it shares some personal information, but it's only that your income is in a certain range and not the exact amount.
Okay.
Okay.
The flow you're showing looks very similar to what the earmark does.
This video, you mean?
Yes, so the flow with getting a QR code and then scanning the code, and then you get that's what I know from the earmark.
Yeah. There are indeed like a lot of self-sovereign identity solutions, or at least identity solution that look similar. That's true. But most of them have slightly differences. So I think for IRMA is, for instance, not using blockchain. So I think it's harder or not possible for them to revoke information that was sent to the IRMA identity wallet, which we noticed for some companies is very important because it gives like added value if you can revoke information. Also for the government, like when you retrieve your income from the tax authority, I think they can still change the je aangifte after 3 or 5 years if there were some errors. So then they still want to revoke the information that was saved in your identity wallet. And also, blockchain also adds timestamping in a decentralized way, so you don't have to rely on a certain party. So there are some slightly differences between identity solutions.
Is there a system in place which handles the expiration dates of certain
certificates? Like the W3C standard for verifiable credentials. It's just a JSON object where you can also have like an expiry date. So you can verify if the date has passed to see if it's expired. Yeah, does that answer your question? Yeah? Okay, cool. Yes? Yeah, I would also maybe explain the process that you just saw in the video for how the identity app exactly works. So what you saw was that somebody was at the website at the Social Housing Corporation and he wanted to apply for the social housing unit. So what happened was that the Social Housing Corporation, they asked a question to the identity wallet. So they wanted to do an income test to see if the income is in a certain range. What was already done in the video was that your personal information, in this case from EDIN, was already saved in the identity wallet, so step 4 was already done. But what happened in the video was that the user went to the tax authority website. He identified himself with DigiD, so he used his DigiD credentials to prove that it was him. And then he scanned the QR code on the government website. So his income was sent to the identity wallet, and also a proof of the income was saved into the blockchain. So that's a decentralized identifier that was saved in the blockchain. And the identity wallet more or less generated the zero knowledge proof. From
which parts of information are now actually stored in the blockchain? Because I have the feeling you get information from the tax office, you have an account at the bank, and you have a wallet on your phone.
Mm-hmm.
So which part goes in the blockchain? Where's the magic?
Yeah, what's the only thing that's going into the blockchain is the decentralized identifier. So that's DIT. It's also W3C standard, and it's basically just a random generated string of numbers and letters. But you can prove ownership of it. So it's more or less a public key. It's the hash of a public key.
Yeah, exactly. So phone is my private key, and then I can match that against the blockchain. And what happens if I lose my phone?
You need some kind of backup. So that's something we are currently researching. You need like a backup of the verifiable credentials that were saved on your phone, and also a backup of your private key, or maybe not a backup. You can also like split your private key in multiple parts and maybe store them at trusted companies. A bank, the government. Yeah, yeah, too. Yeah, and yeah.
There's one question, because I'm not mistaken, you just mentioned that you guys are now in the solution phase.
Yeah, for the employee wallet we are. Yeah.
So can you give us sort of an indication when you expect this to be in production?
Oh, that's
In terms of time frame, just a ballpark.
that's pretty hard. Yeah, so the solution phase. We build it and then we test it with 100 employees. But then we have to make a decision, like, was it successful? Do we want to scale up? But I think 2 years maybe for to have like an identity solution in production. Yeah, and that's I think the case, but to have it like really on that everybody's using it day to day might even take 5 to 10 years. Yeah.
What kind of blockchain are you using for now as a concept, and what do you envision to use when this will be in production?
Currently we're using the public Ethereum blockchain, but still the testnet for the pilot. And that's also, yeah, that's always like a hard decision to make. Like there are a lot of aspects you have to take into account when using a public blockchain or a private blockchain, consortium blockchain. And so we said for the pilot of 100 customers, we can probably use the public Ethereum testnet. But yeah, it's not that trustworthy probably. So in the future, when we really go to production, we have to find some solution for that. Can still be a public blockchain, but maybe also a consortium governed blockchain or sovereign. Yeah, we'll still have some issues with transaction cost, I guess, and scalability. But that's, yeah, we also follow like the roadmap from those blockchains, and we'll see where we end up. But yeah, I'll also tell you something more later, that we have pretty flexible architecture to change blockchain. For the mortgages, I will do a quick live demo, but you already saw more or less in the video, like how the process works. But if you have any question what's happening, please let me know. On the right side, you see my iPhone with the identity wallet installed on it. On the left side is Hyperloan. So Hyperloan is like a demo application to improve the mortgage application process. It's really simple because we just wanted to have like an environment where we can show to important stakeholders how it can work. Sorry. On the right side, identity app, when the customer opens it for the first time, well, it's still empty. There's no personal information in there. So you just got some screens on how it works, how its privacy is guaranteed, and how secure it is, or how it can be secure. And he can like register himself. So registering means like retrieving some basic identity. So in this case, that happens using Eden. Who does not know what Eden is? Not all. Okay, so when you do like a payment on a web shop in the Netherlands, you have the ideal. Probably familiar with that. So that's a payment method used by almost everybody in the Netherlands. But Eden works exactly the same way as doing the payment, but instead of doing a payment, you retrieve like your personal information from the bank. So that that's your name, your address, etc. So that's also in the identity app right now in this demo. So the same way I do a payment, when I use Eden, I select my bank. Or in this demo, I can just select my account from a list, but normally I will identify myself using the method my bank is using. And when I click login, the identity app is making a call to the bank, and the bank is giving like all the personal information encapsulated in verifiable credentials back to the identity app. And in the meantime, also the decentralized identifier is put into the blockchain. So that just happened, and you can see on the right side that there's my personal information retrieved from the bank. And in this case, that Rabobank has provided 22 data points. So that's basically like the start of your identity wallet, and well, in your lifetime you can retrieve more and more credentials over time. And on the left side, Hyperloan, so the imaginary mortgage provider. So when somebody wants to apply for a loan, he can fill in some information about the loan he wants, or mortgage, the type of mortgage, and in the last step, he can choose how he wants to provide all his personal information. So that can be uploading PDFs or even sending some documents over by post. Or he can choose the identity app. If you choose the identity app, you will see that the Hyperloan requires some data points from the identity app. So in this case, it's the personal information from Eden and this financial information from UWV. So that's a company that's in the Netherlands, or a government agency that does all the incomes of everybody in the Netherlands. But those information, the financial information, is not yet in the identity wallet. So the customer can click on the logo of the data point provider, which in this case is just a demonstration environment. So when this is again the government where he authorized himself with DigiD. And well, on the website of the government, his income is shown, but also now a QR code. So you can scan the QR code with the identity app. And you will see the check mark, which means that the personal data is saved in the identity wallet. So you can see there are also now 4 data points from UWV. So now all his personal information is in there to apply for a mortgage at Hyperloan. So he's already back at the Hyperloan website. No. Hyperloan is a pretty old demo we have. Okay, cool, it's working. So he scans the QR code again to share his information with Hyperloan. And you will see that the user has to explicitly give consent on sharing the data. So you see which kind of data he's sharing and the values. And I click on sharing data. The data will be shared with Hyperloan. So you can see on the left side, Hyperloan has retrieved the information from the identity wallet. And it automatically verified that the data was not manipulated, coming from a trusted source and still valid. So that's basically how the flow is for issuing and sharing your data. We'll try to finish in a few minutes. So where we're working on, as I already explained in the beginning, we have the identity app in the middle, the orange part, and working on the back end, so an issuer or an identity platform for issuing and verifying data for companies, which is using currently the public Ethereum blockchain, where we more or less save those decentralized identifiers. Well, we already mentioned it. We are not the only one. There are a lot of identity wallets, and that is something that we also find challenging, because we see that some companies are dedicated to a certain identity provider. So, for example, no, I will not take an example, but it means that, like, in each identity wallet, you have a small part of your information. So, for instance, if the government chooses to use IRMA, then your passport might be in the IRMA app, but maybe your financial information from the tax authorities is in your UPort identity app, and other data might be in another identity app. So we need to solve the interoperability issue between those identity wallets, so that you as a customer can choose only one identity wallet. You can save all your personal information in one identity wallet. And that's why we invented more or less the universal ledger agent. So it's more or less an abstraction layer for identity, where you can plug in multiple modules. So you can have like a module for IRMA maybe, module for UPort, module for the Rabobank identity standards we use. And that means that you can share you can save different type of credentials in one identity wallet. So that's a framework. Marnix is one of the people that have built this framework. We did it also together with Workday, an international HR company that's also providing an identity wallet. So we wanted to prove the interoperability together with them. And I think what's pretty unique is that we made it open source. So it was a huge achievement for us as Rabobank, or as innovation department as well, because we shared all the code we made, for instance, to create verifiable credentials, to verify them. That's all in public repositories on GitHub, so you can also see it yourself at github.com/rabobank-blockchain. And it consists of a lot of modules that can be used within Universal Ledger Agent, but we also have some standalone modules that you can use outside of the abstraction layer. But Marnix can tell you everything about it. And he also has a workshop on 16 November here at Lisk. So that's really a hands-on workshop. He's creating a really nice demo app where you can apply the Universal Ledger Agent and just do it yourself. So that's pretty interesting. And that's basically it. Thanks. Are there any last questions?
Yes, it has nothing to do with any technology. Why is a bank in general doing this? I can understand why the government wanted, why the people wanted, and why the bank would want it to be there. What's the incentive or business model for the bank to actually do this?
I think that when you ask people more, in most of the countries, they see the government, or Western countries, they see the government as most trusted party, and then the banks, and then maybe utility companies or telecom companies. So I think the bank is a trusted party in most countries. So that's why we might want to take a role in self-sovereign identity, but as explained, we can also optimize our business processes. So it might be that we will use an identity wallet that's already in the market, but just to optimize our business processes and offer better services to our customers. So there are multiple ways where how we can benefit. Yeah?
So this slide, open source stuff, was it hard to convince your managers to do it open source, and what was really the right argument to make it do it like that?
Yeah, it took some time, and it really took a long time. I think the most important argument was that, we have the abstraction layer with multiple modules. We published now one module, working on a second one with different technology, different blockchain. And the reason is that we open source this, is that we also want to invite other parties to build their own plugin for the abstraction layer, so that in the end everybody can benefit from interoperability. That was the most important reason to open source it.
And that's the part that your bosses immediately understood why it was.
Yeah, he did. But I have to say, like, Wiebe is our CEO, Wiebe Draaier, and he's also talking for us, he's talking even on the Blockchain Innovation Conference, for instance, in the Netherlands. He's really interested in blockchain and especially identity as well. Yeah. Okay, thanks.
So, good evening. As said, I'm Jelle Millenaar from the IOTA Foundation, official title software engineer, mostly focused on digital identity, as you might expect. So digital identity already means slightly different thing to us than maybe to the Rabobank, as you will discover in this talk, but there are lots of similarities as well. So the title is actually a unified identity protocol on IOTA, and now today I will focus a little bit on machine identities, but I will also talk about the unified identity protocol. So these are the topics that I would like to discuss this evening. So for those who are unfamiliar with IOTA, I would like to give a brief introduction about it, so that you can become familiar with it and understand why we would like to dive into the identity space as well. I will talk about the unified identity protocol, then really dive into machine identities, why that is also important, and also if we have those machine identities, how does that interact with the human identities from, for example, Rabobank that was just discussed. So, welcome to the hyper-connected era. It's a little bit of a new world that we're entering. We already have a world that's quite data-driven. Like all companies really harvest our data to know us as good as possible and try to target us as best as they can with their advertising and everything. But all that data is still in their own data silos. Rabobank probably has a lot of data. They are willing to share it in an open data way, but they're probably one of the few. But once that starts to happen, once we can open up our data, you really start to enable the vision of the Internet of Things. So the Internet of Things is basically the connection of very small little devices which are everywhere, registering the world, sensing what is happening, and that information can then be used to actually improve how we do things in the world, improve the systems that are there. So if we would have this immense flow of data, if we open up all the data which we gather, all the companies, all the sensors, then there are so many new possibilities that we can achieve, so many new processes we can optimize. And that's basically the vision that we at IOTA try to enable with the IOTA protocol. So we really envision a world where everything is connected, everything, all data is indeed open. But in order to really get to that world, a few things really need to happen. One of them is data integrity. You need to trust the data that you sense. So I did a smart city talk like 2 weeks ago, and I said about a smart city can a little bit be like an organism. It can then register data, sense the city around it, and what an organism does, it senses something and then responds to it. Very easy thing to do for them, can be very little things. But in a smart city, something like that can happen as well. The city itself can sense what is going on and then make local decisions on how to do that, or what to do with that. But you need to be able to trust the data. For example, if I'm now going to say that a building is on fire and it will automatically try to send fire fighting cars to it to take out the fire, and there's no fire, well, that's a waste of money, right? So you really need to start to trust the data. So data integrity is very important. And in order to enable data integrity, we need trust. And that's where identity will come in a bit. Automated payments are also something that's very important, very small payments, and it's something that IOTA can enable as well. All right, so most of you might be familiar with blockchain. This is a little bit of the model as we see how blockchain works. You have a bunch of transactions all ready to be added to the blockchain. And once they are added, they become immutable, so they cannot be changed anymore. That's a very strong selling point of blockchain. That's mostly why we use it. And it's also very important for digital identity. Once a DID has been registered on a blockchain, somebody can't just change it a little bit so that they take over your identity. So registering identities on the blockchain is very relevant and very important to do. It brings the trust in the system. It's also decentral. That's something that you would really like with an identity application as well. We don't want to give one company all the power again over all our identities. We currently have that a little bit with internet giants like Google or Facebook, who really take all your data and are in full control over that. And we would like to get a step further and get away from that. But there are some downsides to the blockchain protocol. It's very linearly done. So there's a very low throughput. We see this very funnel where a bottleneck is created, and that leads to a low throughput and therefore also a high transaction cost. So if Rabobank wants to put their application on Ethereum mainnet, they would probably have to pay 50 cents or something for a transaction to register an identity. If they do that for all their customers. May I ask, how many customers does Rabobank have? Can you give me a ballpark number? Or is it?
8.1 million.
Sorry?
8.1 million.
8.1 million. So if they would register all those, that's like 4 million euros. Sorry, Inda? That's only a subset. So there you go. That's 4 million. So that's something that they probably would not like to do. So that's why they said they would still be open to change to another blockchain. Well, I would say, why change to a blockchain when you have IOTA? So IOTA isn't a blockchain necessarily. It's a distributed ledger technology, which is the overarching term for it. And we are also decentral and immutable. So we have the same aspects. But instead of having a very bottlenecked linear approach, we really try to be more parallel. So transactions come in and they are added to the ledger, all in parallel, all asynchronous. And that way we want to have a scalable network. How we do this enables a few very important features. Our ledger is completely feeless, so that means that every transaction is free. That means if you want to send 1 cent, you send 1 cent to someone and it actually arrives there as 1 cent, which is pretty nice. I don't have to pay 50 cents to do that. And if I want to register 8 million identities, it will cost me absolutely nothing. And this also enables a high throughput with our parallel approach. So this is the Tangle in action. It looks very messy, but that's only the computer sees it like this. You don't have to look at it all day to know if your data is there. So we have secure data transfer. Since we have free transactions, we can also do pure data transactions. You don't only have to send tokens around. Yeah, so it's highly scalable. It's also quantum robust. Quantum robust means that we have chosen a signature scheme which is foolproof against Google's new quantum breakthrough, for example, although that's slightly overhyped anyway. But once quantum computers arrive, IOTA will not be affected, which is actually a very important point for digital identity as well, because you don't want your identity cracked through a quantum computer. So that's something that's always nice to keep in mind. Identities need to last your entire life, and they need to be secure for your entire life. Well, I believe everyone here wants to be 120 years old, at least, right? We can do that. So your identities need to be secure for the same amount of time. So that's actually quite a challenge as well. Get this. So with IOTA, we're a base protocol. We're a distributed ledger technology, which means that we don't necessarily specify on one specific topic. There are many use cases which would be applicable to IOTA. In the telco industry, mobility, we're very big into that as well. Digital economy, smart cities, etc. And as you actually can see in almost all of these, is that you see identity come back almost on every single one of them. And if it's not there, it's because there was a higher priority one, but there's always, the identity layer is required for all the use cases on IOTA, because we want to enable digital trust. So the IOTA Foundation is currently the main developer of IOTA. IOTA Foundation consists of now more than 100 people. When we were founded, like, what was it, 2017? There you go. Then we only had like 4 people, so we've grown quite a lot, and we try to keep doing that. And we already are spread across 23 countries right now. So that means that, yeah, I have to get up early sometimes to do some calls or have a late night to talk to my colleagues in Texas. We have a decent amount of funding, and our focus is on research and development of IOTA to actually make the protocol as future-proof and as scalable as we want it to be for a real Internet of Things world, but also support the adoption of IOTA. So, for example, we will gladly help Rabobank to adopt IOTA into their identity application. Even better, if there's someone here who wants to do that, they have open source universal ledger agents, so feel free to just implement IOTA there. I'm pretty sure they will be happy with the contribution. So that's all you need to know about IOTA. I hope it gives a nice introduction, and it shows why identity is actually helpful in this on our platform as well. So I'll give a little bit of an introduction to how we see the identity problem. It might overlap a little bit with the previous talk. So we really see a disconnect between the virtual and the physical world. So here we have the physical world where we all live. We have certain attributes, certain personal data that describes ourselves. Machines have the same thing. They have a manufacturer, they have specific specifications on how fast they are. And these things you can only find them in the physical world. But in the virtual world, there's no real information about this. And if there is information about us or about devices on there, it's actually not trustworthy. So, for example, the internet giants that we have today, they really try to be that trust anchor to connect these two worlds. We have Facebook that tries to make a really nice profile about us, and therefore have a virtual copy of our profile, and then that can be used for other applications to have a pretty good guess of who you are and your attributes or what you find interesting. But that's just data scraping, and that's like there's a chance that they are right, but it's a ballpark idea of who you are. But if you bring your own identity, if you yourself collect your data, who knows you best? It's you. So if you bring that data to an application and just tell them, you don't have to guess who I am or where I live, this is who I am, and I want to make use of your services, and therefore I'll supply all the information you need. There's a way more accurate profile, and many systems can be optimized to do just that. But yeah, it requires trusted data, and that's where digital identity is the key. So here are some examples. The current state, current internet, sometimes it's not online, so versus how it would work in a self-sovereign identity world. So for my personal data, like my name, most of the time a profile scrapes that from either Facebook or Google. And I actually personally gave that data to Facebook or Google. So I can just lie about that. I can make I can take a nice picture of a pretty girl, put it on Facebook, give it a nice name, and that's me online now. It's catfishing, right? So it already happens a lot right now. But what if I can just give you a government-issued identity which is immediately verifiable? Well, that's trustworthy because the government won't accept my female picture as a reference and instead wants to only give out the real identity. So this is way more trustworthy. My work experience. If I show my work experience to my new employer, they will probably check my LinkedIn. They might actually call my previous work for references. So that's actually a nice validation, but it's after user submitted or endorsed by others. However, when there's issued proof from employers that they just say, yeah, this guy worked here and I digitally sign it, it's completely trustworthy. You can see, hey, my colleagues who actually work there, because they can prove they also work there, endorse some of my skills. That's also way more trustworthy. So you can actually start to hire people based on trustworthy data, which probably will save HR some time. A nice example of health. You probably are here thinking, I don't want to share my health data online. That already sounds a little bit annoying. And that's true, but let's say it's needed. Like if you try to search for new glasses online and you have a very specific strength, Google could guess that based on your searches, like, oh, you've looked for this or that, and then it can try to show you glasses which fit that prescription. It might have some appointments on your calendar of what you did when you went to a doctor visit or something, and scrape some data from there. But what if I can just tell a web shop, hey, here's my prescription, please give me some glasses that actually solve my eyesight problem. Then you immediately get the searches that you want. When we talk about digital identity, we talk about privacy very often. And we always say we have to protect our data. But actually, you should sometimes really want to share your data just to make your life easier. I want to share my prescription just so I can get the glasses that I really need. Same with preferences. If you want to go to a web shop, Google can try to scrape some data of the web shops you visit. The web shops themselves do it, of your previous visits. But they're all silos, right? So what if you just hold your full search history and just dump it to them, like, all right, just show me what you got which is interesting for me. Don't just use the data of bol.com or Amazon. Just use it all and give me some nice suggestions. Some people might not like that because privacy reasons, but you don't have to share it. But if you can, it can have some nice applications. So that's really like digital identity for people, right? You return the control of your identity and data back to the person, and that the trusted and verifiable identity lowers the barrier for business, for doing business. But this is not a problem only for people. Like trust in and between organizations is also very important. So the Rabobank probably deals a lot with other Dutch banks, and they might want to share or change loans between one customer and another. And maybe they would like to use the KYC of each other. Then creating trust between these organizations and using their KYCs can be very useful. Yeah, there are multiple ways in which organizations want to trust each other as well. But we also want to trust organizations as well. If we get a bill from an organization, it would be very nice to verify that the bill actually comes from the organization that I expect it to come from, and that I don't pay a fraudulent invoice. That's the same between organizations, right? And here it is. There's also the need for trust between machines. And that really would become enabled by machine identities. And before I go on, I really would like to highlight that all these identities are exactly the same, at least in an online manner. We're just talking about a digital version of an identity which represents some attributes, which needs verifiable credentials. So why would we only make an identity for people if we can make an identity for organizations and machines at the exact same way? And now if they want to interact with each other, I can verify a person just as easy as an organization or as a machine. I can verify that a car is actually the car that I want to buy, that it's not, it's driven way more kilometers than the seller tries to tell me. So let's just make one simple protocol which tackles them all at the same time, and then you really start to create a seamless interaction between all these types of identities. So at IOTA we think this is a very difficult task, a very nice task, but we don't want to create any barriers for this. We don't want to own the identities, we don't want to own the identity software, we would like to collaborate on this. So we try to do that as much as possible. We call it permissionless innovation. So we at IOTA have no idea what identities will be used for in like 10 years. If it's used everywhere, there are so many other applications that are possible on it. You probably here have ideas that I wouldn't have thought of. So if you open up your code, your protocol to others, then it will grow way better. So everyone can then innovate and participate. And how do we enable that? Well, first off, we made all our transactions feeless. So that means that if someone wants to create an identity, it's free. You don't have to be a rich boy. You don't have to even have some money. Like I actually had a discussion just now how in Africa it would be very difficult to do the 50 cents of Bitcoin transaction fees, because that's actually a meal there. So we don't want to create any barrier for this. But also for the organizations or anyone that wants to verify if the data is correct. IOTA is completely public, so you can just download the ledger, you can see the data going through, and if you want to verify an identity, that's always possible. There's no need to ask a company for permission, such as the IOTA Foundation. You can just download it directly. So it's also permissionless, that you can actually verify that the data is correct. So you can actually run your own nodes as well. And it's also open source. Everything we do, we try to make open source as soon as possible. And that means that you can actually start to develop your own applications, such as a nice Rabobank integration, completely for free without any permission from me, for example. How am I on time? Just, sorry, 8 o'clock, okay, yeah, that's fine. So let's actually dive into the topic, what I made as the title. So for machine identities, It's a very specific problem in the IoT world which is there right now. I just came from EclipseCon, and in Eclipse they have a lot of IoT projects going on, and they solve specific problems within the IoT space. And if you combine them all together, you actually get a pretty good IoT stack. So you can really start to program with IoT devices, make them interoperable between each other, make them communicate efficiently. So the IoT world is starting to kick off at the software level. But there's one part which they all miss right now, and that's really that invisible layer of trust. The way that you can actually know what machines are interacting with each other and that you can trust them to be real machines, what they say they are. You can just assume it, but that's not a way that you would like to make these applications. So what happens right now is that an IoT device can very well talk to another IoT device from the exact same vendor. That's no problem. They have a nice identification protocol to show I'm a real Raspberry Pi. But if you then want to talk to something else, like an Arduino or something, then it's suddenly like, oh, well, I don't know actually how that identification works, so I'm not sure how I can trust this. So if we start to create a decentralized approach to have one protocol for identifying other machines, then immediately you can start to talk to all the machines, and it really opens up the world for IoT devices. So that's currently not possible yet. So you can start to standardize specific IoT attributes. So you know, hey, this machine is giving, or this sensor is giving temperature data. I know exactly how that works. So even if it's a Raspberry Pi or Arduino based or a sensor created in China, doesn't matter. I understand how it works because I standardize the attributes, the verifiable credentials that prove that they do this. And it really starts to enable more devices to talk to each other. That's the very important thing here. So one of the things that I really talked about a lot in EclipseCon was edge computation. So for those who are unfamiliar about that term, you have the cloud, which was a nice way to stop wasting resources on our servers. Instead of everyone having their own server, which runs your web application, your website, we decided like, hey, maybe we can just put them all on the same device so we don't waste the CPU resources and they just idle a lot. And that's really the cloud. You try to optimize servers. But now there's also edge. Edge means that we have quite a few devices in our home that when you're not busy with them, they're doing absolutely nothing. That's a lot of wasted resources right now. All these devices could be doing something useful if you would allow them to. So that's what edge computation tries to do. They try to really enable devices to offload their calculations to devices nearby. So you really start to get a very more local network. You don't have to talk all the way with the cloud, which takes way too long. No, you can just ask it to some local machines, hey, can you arrange this for me? But in order to do that, you really need to trust again that they give answers which are correct. So that you know that they have the computational ability to even do these calculations, that they're from a vendor that you trust, that they run software that you trust to do these calculations and those kind of things. Those can all be done and verified through identities. And then you can really start to rely on the data from all the IoT devices around you as well, because you can trust them. So let's dive a little bit into some real more examples. So vehicle identities is a vector that's really being explored as well, which can be useful for many different things. So let's say a new vehicle is created and it immediately creates its own identity. And the manufacturer says, all right, I created this vehicle. I'll give it a credential stating this is a real Volkswagen car with these and these engine, etc., like all the attributes that you need to know. And therefore, you have a nice profile about your car. And then when you want to give that car a task, because cars are going to be autonomous in a hopefully short time period, you can actually ask, hey, this car, can you actually pick me up from location A and bring me to location B? Well, then the car can prove, well, I can actually do that distance because my battery is big enough, and I can load exactly that amount of people into the car as well, because it's, you're with 4 people and it fits perfectly fine. When you want to, when cars need to start talking with each other, which is also a vision that we try to think about, if cars can discuss how the flow of traffic should work, they can actually really optimize what's going on. Like if you're at a traffic jam, what if every single car just starts driving quickly again, like all at the same time? Well, traffic jam solved. We can do that if we can start to talk with other cars. But you need to make an arrangement that everyone agrees on what to do and how to solve it. And therefore, you need to trust, again, the devices that you're communicating with, that you don't get random computers nearby that try to act like a car just to screw up the system. That could actually be an attack vector, right? Where you try to maybe let 2 cars crash because you pretend that there's no car there. Yeah, I actually mentioned that. Yeah. So for the purchasing of tasks, which I mentioned first, we actually have made our first proof of concept, which has integrated digital identities in it, which is the industry marketplace. And you'll see how identity is important for this and how our partners are also important for this.
The industry marketplace enables the autonomous trading of products and services for humans and machines. It provides a trusted, scalable, secure, and vendor-neutral platform for all industries to increase automation, reduce costs, and optimize workflows. How does it work?
Very important sentence incoming.
It starts with identity. Every participant registers through an integrated decentralized identity system. This ensures the authenticity of the participants. Organizations are able to authenticate their own devices after their participation has been approved. The industry marketplace utilizes an open source communication language developed by academic institutes. It enables interconnectivity and is used by the different machines and vendors to interact. The content of each request is described by a catalog of machine-readable attributes and properties. This ensures that other machines...
Oh no, I didn't mean to do that.
...understand which context and criteria are being...
So this is actually quite a nice one. So eClass is one of the collaborators on this project with us, and they identify the types of attributes that specific devices and machineries can have. So you really know this is the type of attributes that a car should have. So in that way you can standardize the type of credentials, and you know, okay, I want a car identity, okay, I receive a car identity, therefore I know it will at least list how many people can sit there, what the battery charge is, how far it can drive, etc. So eClass is very important here. I think they have like thousands of standardized devices. Do you by any chance know? Everything, right? Yeah. So that's a very important partner here.
Requested. The marketplace can be applied to a wide number of industries and scenarios. In this case, a passenger is requesting a mobility service to get to his destination. Starting point, destination, and other important information is described by unique attributes which the autonomous car understands. It then offers a bid on the contract. Through an immutable audit log, all steps are encrypted and documented to fulfill regulatory, financial, legal, and other corporate aspects. After arrival, the buyer pays the car directly through the industrial marketplace, using the integrated IOTA token and without any fees. The industry marketplace is available as open source software and works in public and private environments. It was developed by world-leading academic and standardization bodies, corporates, and thought leaders to allow a secure, autonomous, and vendor-neutral integration for Industry 4.0. To join the industry marketplace, please visit industry.iota.org.
So please do visit industry.iota.org. We have a very nice demo where you can actually try to interact with some of the machines. You can even pretend to be a machine, which goes against all the principles what I just listed, but it's just a demo, right? But that means that you can actually also use this platform to start creating these applications. It's more than just a demo. If you want to build like a decentralized Uber, then feel free and go ahead. So these are some of the use cases that you could do with an industry marketplace. Mobility services was listed just now as one of the examples. City chores could be a thing that can be picked up by both a machine or a human. Like if you want your grass cut, then maybe like we have one of those automated grass cutters that you can just slowly drive to your lawn and do it for you. Or maybe there's a cheaper person or kid that wants to do that. They can all negotiate that over the industry marketplace. Package delivery, again, something that both machines and people could do. And since the identities are exactly the same, all this interaction over the industry marketplace is done in a very easy way. So maybe let's have a little moment where you can ask some questions if you have about the industry marketplace or what I said before, because I keep talking very quickly. Sorry?
Which industries already applied for the IOTA marketplace service?
So this is a fairly new project for us. It's currently focused really on the industrial side, so that machines within factories can start negotiating with each other. We were working, it doesn't say that, I believe WeWash, which have like washing machines that they can prove how much their load can handle before you actually try to get your clothes washed there. So it's very much in the exploration stage right now. But this is a continuous effort of us. This isn't just like a proof of concept that we dump on the internet. So we happily invite other companies, corporates to either contribute or start building on this to try out the software. But it's not like in production somewhere right now. Yeah.
I might be wrong. I do see a difference with the decentral ID in that there is no blockchain which records the public key, let us say, with a central authority that has the information of the IoT device. I'm not saying that that's a solution, but is there something to say about that?
Sorry, I don't really understand the question.
Maybe I'm wrong here.
No.
The DID has, for example, income information with the tax authorities, and they ask for that income information, and in order to prove that it's valid, there's some secret information recorded in the blockchain.
Yeah.
That's a solution, I understood, but that's not the way this works, right? It's the IoT device which has all the information itself.
So in the example of Rabobank, you store your data about yourself locally on the phone. And you provide that data, but it was signed by an authority. And the same can be said for IoT devices. Right. They can store their own attributes, the data about them, but it's signed by the manufacturer, for example, beforehand.
Okay, so that's similarity.
Yeah.
Where does the blockchain get into the ID then?
So it's very similar to what Rabobank said. So you register the DID on IOTA, and if a verifiable credential has been revoked, so as was said before, that's also registered on IOTA. So you can, when you receive a credential, you first check, okay, who signed this? Let me check on IOTA if that is actually the party that I expect it to be and that it was signed by the correct key, etc. And then you also check, okay, so if there are any problems, if it's revoked, I should find it here on IOTA. And if you find it, you know it's revoked. And if you don't find it, you know it's still an active credential. So you would accept it as truth.
And we will still get to the point that the IoT device gets or gives correct information, or is that?
Yeah, so like it's always tricky, right? Like with a digital identity, you can't necessarily prove that it gives out correct information. It can help though. So if you know that the device has a credential from a manufacturer, you know at least that is a correctly made device. So there's a better accuracy for the values that it gives out. There are also ways that you can test what software it's running. And if that is software that you trust because it's given out by, it uses the most latest open source software, you know that that is also correct. Therefore, you can trust the data that comes from it. However, if I move a sensor, a temperature sensor, and just move it to next to a heating, a place where it's very hot, then obviously the data is still a little bit untrustworthy if you're trying to get the average temperature of a room. So in that case, you probably would do it quorum-based, so you ask multiple devices for the same question, like, hey, how hot is it in Utrecht? And if there's one which is completely higher than the rest, you just ignore that one. So trusting data is always tricky, and there will never be a way that you can 100% trust it, but this makes it way more trustworthy than it was before. Good answer? Yeah? Okay. Yeah. Any other questions? Yeah.
Question about like the velocity of the process, because if you start talking about IoT and you have about a quorum query, then there's like gazillion data points about what's going on in Utrecht. But how can I find Utrecht? How can I find the devices that I'm looking for?
Okay, so this is actually a very interesting question because with people, now actually comes a slight difference between the identities. Because with people, we have this very difficult thing called Gdpr, which means that we have to keep data private. So we can't put it on blockchain or IOTA, right? But devices don't care about their privacy. So a device can actually show its verifiable credential that it is physically located in Utrecht, for example. And if you want to filter on that, it will immediately be able to find such a device. So there can be open credentials in a way that showcase those kind of things. I'm not sure if that will work with the performance, but in the way that we see IOTA scale, we always assume that you only start to see more locally. So you don't get transactions that happen in America. We don't care about those anyway. Like, if a temperature sensor in America picks something up, like, I don't care here right now. So I just want to know what's happening nearby. So that's how we see IOTA scale in the future. So that kind of already has a pre-filter built in a way.
So does it then mean that I'm somewhere, actually because in blockchain of course you have the long line of data, so you put something somewhere, but in this case you're actually positioned somewhere in the tangle, so you assume by closeness that probably the first responders are around me?
Interesting concept. I think you should talk with Olaf, because he's like really laughing in the back. He really loves that concept, and I think he's like the only person on IOTA who really is thinking about this, well, in the IOTA community. So you should definitely have a chat afterwards, because he has a lot to tell about that. But I don't want him to steal my talking time now. No. Any other questions? All right, then I'll continue a little bit more. So my previous employer was actually VX company, and I was also working with IOTA there, also with digital identity. And we had this very interesting case with Vialis, which some of you might know if you're really into like traffic lights. Not sure, could be your thing, right? So Vialis actually makes intelligent traffic lights, which you probably want to assume is already there, but traffic lights generally are not that intelligent. So they actually are doing a better job with that, meaning that the traffic lights can actually, they're hooked up to the internet, which is pretty standard, but hey, it's an improvement over before. And they can start to make decisions based on data that they receive. So we had a case with them where they said, we want to give fully loaded trucks the right of way when they go through a traffic light and it was still on green and it's going in the direction and the light just stays green for like 2 seconds longer to let the truck pass. So why do you do that? Because if a fully loaded truck stops suddenly for the traffic light, it takes 1 liter of fuel to pull up again to the original speed, which is a lot of CO2 emission that you put out directly into the city, which is not very nice. So if we try to make such an application, we really want to be able to trust the truck. Because if I can get the right of way in my car by just cheating about who I am and just pretending to be a loaded truck, I will definitely do that because I really don't like red lights. So we really want to have this secure, and therefore we want to be able to let the truck prove that it's actually a truck, which was registered by a transportation company in the Netherlands that the traffic light recognizes, and that the truck can even prove what load it is currently carrying. That can be both be done like by the manifest that it has, so it can prove what it's currently carrying, or by like IoT sensors in the asphalt, which registers the weight that's currently on top of it. And combining all the data, you can have a pretty accurate idea of it if it's actually a loaded truck. And then we can just give them the right of way without having any issues where people try to cheat the system. So this is one of the ways where identity is really important, because people would love to abuse it. So yeah, you really start to negotiate with the traffic light when you're starting to get closer. You say, hey, I'm coming your direction. If you are currently green, please wait for me. And here is all my credentials to show that I should have the right of way. And then the traffic light can quickly check on IOTA, are these valid credentials by issuers that I trust? Okay, I give you the right of way. So obviously this needs to be a fast process as well, because trucks drive really quick towards the traffic light. So that's already a very tricky application, and it needs to be done very well. So we made a slight, small proof of concept here with simulations where we tried to simulate how traffic works and let a truck get the right of way, which actually ended up working. And it immediately became a nice IOTA stress test, because we were posting the GPS location of the truck like 20 times per second for multiple trucks in the simulation. And that was a nice stress test immediately as well. So another case where identity and trust is really important is the British T-Spike. I also used this one at the previous IOTA meetup, which was here. It's personally one of my favorites. So at 6 p.m., everyone in England decides, let's get some tea. It's very important for our culture to keep that up. So they start to boil their water, often like electronically now, because we're modern. And you get this huge energy spike here at 6 p.m. Like this is the entire British national grid and how much electricity is happening or is required. So renewable energy is actually able to catch like the average energy spent which is happening in England pretty well. However, if there's a spike at 6 p.m., that means that it needs those coal centrals to be active and produce electricity to handle that spike. But they take a lot of time to heat up. So actually at 3 p.m. they start to heat up, and after the spike is done, they still need to cool down and they still produce energy, so they shut down around 9 p.m. So that means that you actually have 6 hours of coal burning to handle a spike which sometimes only lasts like 15 minutes. So obviously this is not what we want, and it's even worse than you think, because if we're producing coal energy anyway, then we might as well just disable the renewable energy that we're currently gathering for a little bit. So we're not only not using it, we're just like throwing it away, which is really weird. So what we want to do is actually reduce that spike, reduce the spike of energy. So how do we do that? Well, the British are very consistent in when they have their tea. So what if we just ask, for example, all the fridges in England to lower their temperature a little bit just before the spike happens. So you actually consume more energy to do that, but then they can shut off during the spike, which means you can lower the height of the spike of energy required in the entire country, meaning that we might be able to do all this with just renewable energy. And that's a very nice case to have. But yeah, fridges are not just going to do that because, hey, they're nice fridges. No, they want to be paid for this because they need to earn money as well, right? Get bread on the table. So we pay them actually for this, to do this. But yeah, people are going to abuse that. Because what if I just have a Raspberry Pi that pretends to be a fridge, or maybe like 100 fridges, and just says, oh yeah, I lowered my temperature, and there you go, pay me. So what we want, if we want to do this, if we want to reduce the energy spike, we need to be able to identify the fridges, know what they're doing, show proof that they actually are reducing their temperature beforehand, and that they have no energy requirements during the spike, and therefore we can actually build this in. So as you can see, IOTA is super renewable. And the last thing that I would like to highlight, I'll keep this one a little bit shorter, is the human-to-machine interactions as well. Because we just talked about the machine identities for a little bit. And yeah, there are also ways to improve our lives directly. So this is one of the cases that I often mention is, let's say you want to rent a car. Right now, if I want to do that, I need to register myself at one of the car sharing companies here in Utrecht, which we actually have quite a few of. And then once I'm registered, done the KYC, I can start to maybe ask for a car, reserve it, and then drive off. But what if I need a car right now and I haven't done that? Well, what if you don't have to register at the company? What if you can actually have your own self-sovereign identity on your phone, which shows that you have a car insurance for shareable cars, you have a driver's license, and you actually have never been like ticketed for bad driving, right? If you have those credentials, show that to the car might say, all right, you can pick me up. But even better, the car can actually prove, hey, these are my attributes and I can bring you to the destination that you want. And here is my latest APK, no idea how to translate that, but sorry?
MOT.
Okay, there we go. MOC? MOT. Okay, there you go. MOT for the English-speaking people. And therefore, I'm a car that you can trust to bring me, that you will actually be able to drive to your destination. Then you can immediately unlock the car, start paying for driving while you do that. And yeah, you don't need to do all the registration beforehand. So this just makes our life a little bit easier, right? So the same with logging in. It was also mentioned by Rabobank again. I currently have 110 plus accounts online, which Google nicely tracks for me. And I never reuse a password, so I just remember 110 passwords, which I change every 3 months. And this is a perfectly normal system that everyone uses, completely secure. But let's make life a little bit easier. What if you can just log in by a single sign-on on your phone, where instead of logging in with Facebook, you just log in with your identity and say, okay, here's my account from the last time that I came, please let me enter, and it does that. So you don't have to have a unique password for that specific application, and I can just have a single app to do all this. For example, you can easily get just a prompt like, hey, Facebook asks for a login. And then you say yes if it was actually you, and if you're not currently trying to log in, then probably someone is faking to be you, then you just say no, and there you go. Very easy way to now log in online. And yeah, people might recognize this as well. For those of you who are not like me and have a job where you actually go to an office, of course I sit here very often though, but you often have to pass these gates and you have this nice card that you always have to carry with you, and if you forget it, that's kind of annoying. Then you have to like go to the desk and ask for a replacement, or you have to go home again and pick it up, which my girlfriend sometimes does. And it's very just annoying. So it would be very nice if you can have all your access cards, everything that you currently have on your wallet, all those cards neatly as verifiable credentials on your identity on your phone. So I can just enter this building here at the start because I am part of the Lisk Center, and I can just go through to the train, beep in there, immediately your payments are done automatically through IOTA, for example, but could also be connected to another account, etc. You can just, why do we even have a wallet nowadays? We have a very clever device always in your pocket. Like, we really need to get to that place. So I've talked a lot about like what can happen, and the Rabobank actually was able to show you that they're working on it. So with IOTA, we're still in the beginning stages of this. We have a clear idea where we want to go. We have done our first implementation with the industry marketplace, and now we're also really working hard towards showing how these things work on IOTA directly with a nice application. So hopefully you will see more about that in the near future. So definitely keep up with the news of IOTA if you want to hear more about this. We have a very good Discord for those of you who know it, where you can ask all the questions about it, or you can follow us on Twitter or something like that. This was my talk of the evening. If there are any questions, feel free to do so right now or afterwards at the beers. Any questions left? Yeah.
If you do machine-to-machine interaction, then you'll follow up with the payments, I guess.
Could be, yeah.
How do you settle the payments?
So IOTA is a cryptocurrency as well. So you can beforehand make a decision, make a contract between the two, stating like, hey, I do this service for you, and you pay me this in return. And then when it's done, you just send it over IOTA, and you say, okay, please send the payment to this address. And the payment can be done in a very quick manner.
And then it's still in IOTA?
Yeah, yeah. We are trying to make the machine economy happen. So IOTA is really made for those machine-to-machine payments. So we would like to believe that in the future, if this would get standardized, what we're trying to do, IOTA tokens would work fine. If it ends up that machines don't want to hold IOTA tokens, there might become like a decentralized exchange where you can quickly change them to something else, which can be hooked into this. But we'll see how the future goes before we go there. Other questions?
How can it be free?
How can it be free? IOTA or?
Because I see a lot of really cool stuff going on.
Yeah.
And I really would love to pay the IOTA Foundation every time 50 cents just to not use a bank. Why is this free? How?
So I'm going to go like all the way to the start of the slides. Yeah. So here's the animation. These are all single transactions that are happening on the IOTA network. And you always see when a new transaction comes in, it starts to have a link with two other transactions. That is a hard requirement by IOTA. Every transaction must reference two others. But what actually happens is that when you do that transaction, you validate those transactions that you reference. So you check, hey, do these follow the rules of the IOTA protocol? Do they spend money that they actually have, or are they trying to spend money that they don't have? And if they spend money that they don't have, you don't reference it. So you actually help the network as you do a transaction. So therefore, we don't need a miner to do all that, to do the security. You yourself, when you are part of the network, help the network, and therefore you have to pay nobody. So let's say what would happen if you reference a transaction which doesn't follow the rules? Well, then another transaction would like to reference you, but it realizes that it doesn't add up how the network works through your transaction. So it will mean, we'll see, hey, this doesn't work, I'm not going to reference you. So if you decide to be a bad player, your transaction will actually fall out of the tangle. It will be like left hanging here on the side. Nobody will reference you, and therefore you will be seen as a child chain which is not referenced anymore, and we don't see that as truth. So if you play fair, you help the network, and the network therefore helps you by referencing you, and you become part of the network. If you actually cheat the system, if you're trying to allow the breaking of rules, then everybody will turn on you and say, well, I'm not going to reference that, and I don't want to be associated with that, and you are left out of the network. So in that way, you actually get a very big incentive for only truth to happen throughout the network.
Can you repeat what was checked, whether they have enough money?
Yeah, there are a bunch of checks going on, right? So you have to basically validate the ledger. If they try to spend money which is being spent at the same time for something else, then there's something off. If they try to spend like 100 times more money than they have, something's off.
Are
Like
they validators?
basically every transaction is a
The
validator.
notes are the validators.
No, the transactions. At the same time, the nodes can also kind of validate. They could, I don't think we do that right now, but they could decide to not propagate transactions which are invalid throughout the network. So there are multiple levels of validation. What I do like to be transparent about, this system that we designed really needs a high throughput of transactions to be secure, because that's how it works. And we currently don't have that yet. So what we have is a single node, which we call a coordinator, which puts one transaction in every 2 minutes, and everything that it references then becomes immutable. So that one, those transactions, like direct and indirect, are now considered truth. And that money is then spent. So that it currently is run by the IOTA Foundation. So, but you can still look if it doesn't try to cheat the system. If it would ever try to cheat the system, then the whole network would say, well, we don't trust the coordinator anymore. So there are still safeties like that built in. But we are actively trying to get rid of that, because that's a centralization aspect that we don't want to have in the network, and it doesn't scale anyway. Yeah, in the back.
Like, at which scale will you be able to remove the coordinator?
So we have an entire project for this, which we call Coordicide, which literally means kill the coordinator. It's heavily in research, with like a whole team working on it. We have a nice website about it with our current concepts called coordicide.iota.org. So feel free to have a look there, or ask me afterwards for more info on where to find that, if you want to read more about it. There was another question. Yes?
So what if somebody steals your phone and has your password?
So if someone steals your phone, that's a little bit annoying, of course. But indeed, they would need to log into the identity app to really start abusing your identity. So then it's all about local security. How secure is the identity app on the phone? So what is often recommended, and I think most identity apps will do, is every time that you want to confirm an action that you do as a person, as an identity, you often use biometrics to confirm that it's still you on the phone. And if you can't pass the biometrics test, then you can't actually issue a transaction about an identity or try to verify your identity.
Do you do that for IoT devices as well? Ask for its dimensions, its attributes?
Interesting. So, like the biometrics of a IoT device could be indeed the manufacturer credential and the software credential to see if it still is running the latest software which you trust. So kind of, you can always ask those. But yeah, it's a little bit more tricky in that way. Yeah, that's a good question though, I like it. But sorry, I can't answer it more detailed. Other questions? Okay, yeah.
What indeed you lose your phone, you cannot authenticate. How easy can you start all over again? You know?
Yeah, so
you end up in the place that you cannot say again that I'm that person.
yeah.
Sorry, you're not.
So if you lose your phone, there are multiple ways to handle that. So first off, you can always start rebuilding your identity if you would want. That's the most straightforward way. If you didn't have a backup, then you basically, I would have to go back to the Rabobank and say, hey, can you verify my identity again? I would probably have to show my face to show that I now have a new digital identity, so they kind of want to confirm it's really me. And I could rebuild my identity. Another way is to actually just back up all your identity data, encrypt it, and for example, put it on the cloud. Since it's encrypted, only you can decrypt it by typing in a password again. But there's actually another concept that we're quite in favor of right now, which is splitting off the identity application and the identity storage. So right now you store, with the Rabobank, you actually store the data locally in the phone. But what if there's like a device somewhere which stores your personal data for you, so your own personal data vault. And you could have a device in your home that does that for you. So it's completely secure, but not everybody wants to buy a device, so you could have specific services that do this for you. And there are actually quite a few developing right now. One of them is called Solid, which is from Tim Berners-Lee, the creator of the internet. He's working on this kind of concept, but in the Netherlands we also have similar ones like Slush, or I think I say it correct, but I don't know actually. So there are multiple ways to handle that. I'm personally quite a fan of splitting off the data of the app, because, for example, if I have the Rabobank app which handles my data, and then I want to switch to the Trinity app of IOTA to handle my data, I don't want to have to like do a very complex way to move the data from one to the other. But if it's in a personal data vault which is separated from the app, I could actually use both apps at the same time connected to my same data vault. So if I have another employer that wants to handle your personal data as well, but integrate them in their own app, then that works as well immediately. So you have less reliance on a single identity app, but you can just use your personal data wherever you want. So that's my personal futuristic vision for this. And that would actually help a lot when you lose your device if you have it that way. To come back to the question.